everyone, my name is Paula Cáceres Burgos. I'm a Master in Astronomy student at the University of Chile, and today I will talk to you about testing the efficacy of the search of intermediate mass black holes through optical variability, guided by my advisor Paulina Lira. So the origins of non-stellar black holes go way back to the early stages of the universe, where the seeds of black holes were formed. Some of them developed to be the supermassive black holes that we can observe today, while the others, due to the belief of lack of interaction, are the ones nominated as intermediate mass black holes or IMBH. Why is it important to study the latter? Well, because of the former belief is that studying the galaxy host of these small black holes could help us find the environmental conditions of the former seed. Therefore, with this information, we can help discard or accept some of the current theories of seed growth and formation. So, studying these small black holes, that is NGC 4395, is that Martinez Palomera and my advisor found that there was a correlation between active small black hole and the fast variability in the optical in timescales of hours. Therefore, they used this latter criterion to search for new IMBH candidates and found around 500 of them, all presenting fast variability features. These are the ones that compose the search for intermediate mass black holes in nearby galaxies, or sibling survey as short. Because I want to know how effective it is to select small black holes through optical variability, is that I select two samples. One is the variable sample, that is the sibling survey, and the non-variable sample is selected in a similar way as the siblings, but with the main difference being that I'm searching for non-variability features, such as that the light curve of its magnitude in the optical doesn't deviate too much from its median. For all of these spectra is that I do a search for AGN signatures, and these signatures come from the broadline region, that it is a gas that surrounds this black hole and produces broad components to the Balmer emission line, such as the one that I'm showing here, found by Chilean, where the broad component is centered in the H-alpha emission line. It is specifically this broad component in this line that I will be searching for in all of the objects. So the way I approach this problem is that I propose two multi-component Gaussian fits, one with a broad component and the other without. To both of these, I compute the reduced chi-square statistic to differentiate between which model is better to the given spectra. And I select as candidates the one whose reduced chi-square statistic is closer to 1, while also doing some visual inspection. Lastly, the mass estimation I computed through the empirical correlation formula derived by Reines that uses the full width of maximum and the luminosity features of the broad components of the H-alpha emission line. The errors for this mass is computed by Monte Carlo sampling. So, for the results of my study is that I found 5 candidates for the variable sample and 16 for the non-variable sample. Doing a little bit of mathematics between these two columns is that I searched that there was around 1% of success rate of finding a candidate of IMBH. And here I show some of the highlights for the variable objects alongside their logarithmic estimated mass in solar mass units. And here are some highlights of the non-variable objects. So, to conclude this presentation is that the efficacy until now is inconclusive. This could be due to the fact that I applied a multi-component profile for the emission lines that may not be adequate for these data. Therefore, a non-parametric approach could be used in a later follow-up work from this study. Also, the high error bars for the mass estimation could be due to the quality of the data not being at its best. Therefore, obtaining better quality data could help us constrain the broad components of the objects and therefore estimate better masses for these objects. Thank you so much for listening, and see you next conference.